Hello, future math teachers. We're going to continue on with domain 3, which is our measurement and geometry domain. And we're going to go through just a couple examples, try to help refresh you on some of the formulas you may see. Here's the topics for the second subdomain that we're going to work with. Um, there's a lot of material there, so we'll go through a couple example problems, but this should give you an idea of some of the concepts you will see. Okay, so let's go through our first one here. Get the pen activated. There we go. Okay, so two angles are complementary. If one is x degrees, what is the other? So complementary, remembering the definition of that. So that's telling us that the sum of two angles is 90 degrees. So that's a formula that you need to remember. And we're given that one of them is x. So x degrees plus an unknown, which we're trying to find, so let's just call it y, equals 90 degrees. Okay, we know that the two of them must add up to be 90 degrees. So if we're trying to find y, then we solve for y. And we would subtract x degrees over, and we get y equals 90 degrees minus x degrees. So that would give us c. So again, going through and remembering complementary, supplementary, those types of things, being able to set up equations and solve equations, dealing with the information you're given. Cool. Give you a second to read over this one. Okay, so what is the measure of each interior angle of a regular hexagon? So I looked at the reference sheet to see if there was anything there for you. There wasn't. So this is something that we're going to have to think about and try to remember. So a common knowledge, I guess, would be that a triangle has a sum of 180 degrees. Okay, that's one that we're familiar with. So you can try to remember common ones, but most likely you're going to run into some that are a little less common. So the formula for finding the sum of the angles, which will be the start of our process. So if you know the sum of the angles formula is n minus 2, the number of sides minus 2 times 180. And we can test that with our triangle, 3 sides, 3 minus 2 is 1 times 180. Okay. So if you know one formula, the sum of the angles, then you can sort of generate the one we want. We want each. So we need to identify that our hexagon has 6 sides. And the n is the number of sides. So if we're looking for each angle, then we would take the sum and divide it by the number. Okay. So we're just dividing the sum up to find the individual. So we go ahead and plug in 6, and we have 6 minus 2 times 180 over 6. You can subtract and reduce. That gives us 4 times 30, which equals the 120. So some of the formulas that you hopefully remember will allow you to generate other formulas that may fit the situation you're working with. So you just have to be flexible as you go through there. Okay. Let's look at one more that requires us to maybe generate what we need. Okay, so what is the lateral surface area of a cylinder with radius 4 centimeters and height 10 centimeters? Okay, so if we draw a cylinder, just a quick draw, just to think about what we're doing. So we're trying to find the surface area of the lateral. So this all the way around. Okay. So if you look at your answers, most of them deal with pi. We're not given pi in our problem. We're given centimeters and centimeters. We want centimeters squared, so most likely we're going to do some multiplication here. So that should give us a little bit of an idea. But if you think about this little portion right here, if we just think about one of these, we have the height times this little piece, length times width would give us this little area. We think about that little area. Well, what ends up happening is we have these all the way around. So we're going all the way around the circle as one of our parts. Same thing on the bottom. So the formula for the lateral surface area ends up being the height times the distance around the bottom and the top, which is a circumference. So our lateral surface area is equal to the height. Now we need to look at what figure we're dealing with. We're dealing with a circle. So we have 2 pi r as our circumference, since we're dealing or given a radius. I mean, you could use the diameter instead of the 2r. So from here, it's plugging in the information. So we're given that it's 10 centimeters times 2 times pi times 4 centimeters. So we get 20 times 4 is 80. We have our pi, and we end up with our centimeters squared. So thinking about maybe how to get there, drawing a quick little picture. Doesn't have to be perfect. This is clearly not perfect. But just to start thinking about the process, start thinking about answers. You know, you're given centimeters squared, so you know you're probably multiplying them together at some point. You're given a pi, so you maybe start thinking about, you know, what formulas do I know that have a pi in them that may be a part of this, and work your way through. All right, I hope that was helpful to get you going on this part of Domain 3. Have a good day.